Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. I hope all of you are doing very well. As you know, dear student, last week we have covered question 3, 4 and question 5 from tutorial sheet number 2. And this week, inshallah, we will cover question 6, 7 and question 8 from tutorial sheet number 2, which is part of high voltage engineering. So today, inshallah, we will finish tutorial sheet number 2. So before I start solving this question, I hope all of you have a small note and calculator. For the calculator, I want you to doing practice by calculating with me during solving the question, and for the small note, so if you have any doubt, any misunderstanding in any question, I want you to write it down, because in the end of this session I will give you time to ask all your questions. So I will start reading question 6, 7 and 8 and solving the questions, and in the end of this session I will give you time to ask all your questions, and I will try my best to explain everything for you guys. So let's start doing question 6. So in this question, he asked us to draw the basic circuit of single impulse generator. And then he asked us to write down the output impulse voltage equation. So he wants here to write the formula. And after that, he wants us to draw the output waveform, which shows that the voltage is superposition of two exponential functions. So this is almost theory part. So inshallah, I will try to explain to you, and after you attending the lecture with the doctor theory part, you will have a full knowledge about this question. Okay guys, so let's move on to the answer sheet. So this is the basic of single impulse generator. This is the circuit, will look like this. So how does this circuit will operate? As you can see, this is the circuit of single impulse generator. So we have a different component like RC elements here. Okay guys, and the test object will be here. This is the test object will be here, and the element, as you know, are C1, R1, R2, C2 and the G, which is the spare gap. Okay, this is a basic structure of single impulse generator. Moreover, we are having a DC supply over here. Okay, now let's ask familiar individual components. First and foremost thing, I would like to introduce you the spare gap, which is G. This is the spare gap, which is G. Okay, the duty of a spare gap is, it is a voltage sensing switch. It will acting as a switch, and we can say that it is a voltage limiter. It ensures that how long the capacitor charges, whether the capacitor is getting charged or not, it is going to sense. Once the capacitor C1 gets charged completely, the spare gap G is going to conduct, then it provides a discharging part. And so that is the duty of the spare gap. So I give you a small definition, a short definition about the spare gap here. You can relate it to this. Okay, now let's move on to the second element, which is C1. So this is the important components related to single impulse generator. It ensures that the main function of capacitor C1 is charging as well as discharging. In the first stage, it is going to charge completely. Later, it is going to discharge. That is the main duty of capacitor C1. So, in the single impulse generator, we will having group of capacitors that is going to charge seriously and discharging parallelly. Okay. Now I will move on to R1. Okay. R1, it is known as a damping resistance. It helps to control the waveform. That is the main function of R1. Okay. Now I will move on to R2. R2 is it is to adjust the waveform as well as wave tail time. Now let's us look to the C2. What is the main duty of C2? It is the capacitance of connecting leads. There are a lot of connecting rates will be happening in single stage impulse generator. C2 represents is basically a parasitic capacitance. So now I have explained how this circuit will operate. So now let's move on to the formula. How can we write this formula? So VT here, VT will be equal V output dividing by R1 into C2, open the bracket, into beta minus alpha. And here also we will multiply this by e to the power minus alpha t minus e to the power minus beta t. Okay, this is the formula will look like. Okay, so the formula for the alpha. So how can we find alpha? Alpha, it will be equal 1 divided by R1 into C2. And the beta will be 1 divided by R2 into C1. Okay? So how can we find the V peak? As this is the waveform, it will be look like this. So the top of the wave, this is our V peak, the voltage peak. Okay? The peak value. The peak value in the top of this wave here. So the peak value will be equal V output divided by R1 into C2, open the bracket, beta minus alpha, and multiply by alpha divided by beta to the power alpha divided by beta minus alpha, and into 1 minus alpha divided by beta. So this is the formula to find the V peak, the value, the peak value. So if you have in the other question, if he asks you to find the peak value, so you can use this formula and you will find the peak value. Okay here. So T1 and T2, how can we find T1 and T2? In the other question, he will ask you to find T1. So the formula for T1 is ln beta divided by alpha, all of this divided by beta minus alpha. So this is the formula to find T1, and T2 it's equal T1 plus ln 2 divided by alpha. So if you have all of this formula, you have only substitute the value. So here, how can we know the value of T1 and T2? T1, by using this formula, we can find the T1, and T2, by using this formula, we can finding the T2. So how much for the T? The total of T. Total of T, it's equal 0.6 T1. Why we use this 0.6? 0.6 here, if you calculate this from 30% to 90%, this all of this is T. Okay? Why we multiply by T1? Because the T1 is from here to here, from 30% to here. This is the value of T1. So when we find the value of T1, okay, we can find the value of T, because the value of T, it's 0.6, which is 60%. It's between 30% to 90% is 60% into T1. Okay, guys? So this is a question 6. So now we have done question 6, and you will have a full knowledge about this after you attending the lecture class with Dr. Abdulaziz, inshallah. Okay, now let's move on to the question 7, which is question part. I will start reading question 7 and then I will start answering question 7. In this question, he asks us an impulse generator has a design value for alpha and beta as. So alpha here he give us 0.0146 into 10 to the power 6, and the beta he give us beta as 3 into 10 to the power 6 respectively. And he give us R1C2, it's equal 0.345 into 10 to the power minus 6. So the first require here, he want us to find front time, T1, and the tail time, T2. We already have the formula for T1, and we already have the formula for T2. And he asked us to find the peak value of the impulse input voltage and the efficiency if the DC input voltage V output is equal to 100 kilovolt. So we have here so many required and we have so many giving value. But the good thing that we have the formula. I just explained the formula in question 6. Okay, guys? So let's move on to the answer sheet and see this question. How can we solve this question? So in this question, in the question 7, the giving values, he give us alpha as 0.0146 into 10 to the power 6, and he give us the beta, it's equal 3 into 10 to the power 6, and give us R1C2 as 0.345 into 10 to the power minus 6, and the V out it's giving as a 200 kilovolt. So the required, he asked us the first thing to find the front time, which we called it T1. So the formula for T1, it's equal ln beta divided by alpha, this all divided by beta minus alpha. So we have the value of beta here, and we have the value of alpha. Also, we have the value of beta and alpha here. So we only need to substitute the value in this formula and doing the calculation. So please try to do the calculation by yourself and see if you get the same answer here or not. So if we have doing the calculation, the answer, if you use the calculator, your calculator, and put the value here, you will get 1.783 into 10 to the power minus 6 second. And if you change it to millisecond, it will be 1.783 millisecond. Okay. So since we got T1, here the total of T, he didn't ask us to find the total of T, but I want to show you how to find the total of T. So 0.6 is a constant, and T1 you can calculate it. So T, it's equal 0.6 into 1.783 millisecond. It will be equal 1.07 millisecond. And now we have done the first required in this question. Now let's move on to the second required in this question, which is T2. T2, the tail times. The tail times equation, it's T1 plus ln 2 divided by alpha. So T1 we just calculated, we get it as 1.783 into 10 to the power minus 6, which is millisecond, okay, which is second, plus ln 2 divided by alpha, which alpha is 0.0146 into 10 to the power 6. So if you use your calculator, if you put this value in your calculator, the value of T1 and the value of alpha, you will get this answer here, which is 4.925 into 10 to the power minus 5 second. And if you change it to millisecond, T2 will be 49.25 millisecond. Okay, so now we have done the question 2. Let's move on to question 3, which is the peak value, which is VP. The formula of the peak value which I explained before. V output divided by R1 C1 into beta minus theta, and all of this is multiplying by T alpha divided by beta to the power alpha divided by beta minus alpha into 1 minus alpha divided by beta. So if you substitute your value here, so V output here, it's giving in the question as a 200 kilovolt. R1 C2, it's giving in the question as a 0.345 into 10 to the power minus 6. Beta is giving the question as a 3 into 10 to the power 6, and alpha it's giving the question also as a 0.0146 into 10 to the power 6. So only you need to substitute your value in this equation. So after you substituting your value, the value in this equation, you will get the answer as this as 188,269.13 volt, and we will change this to kilovolt because the V output as a kilovolt to make it easy for us. So the VB it's equal 188.269 kilovolt. So now we have finished the third part of this question, the third required in this question, and everything is only to substitute the value in the formula. Okay guys, so now let's move on to the last required in this question, which is the efficiency. We will give this symbol to the efficiency. So the efficiency it's equal VB divided by V volt output volt into 100. Okay, so the big value here we just calculated, we got it as 188.269 kilovolt, and the V output is giving the question as a 200 kilovolt. So we will multiplying this by 100. So if you use your calculator, you will get the answer as 94.13%. So now we have done question 7 from this tutorial. So everything is clear. We have only substitute the value. So we need only to remember and understanding the formula and substituting the value in this formula. Okay guys, so let's move on the last question from this tutorial, which is question 8. So in question 8, he asked us to draw the circuit diagram of both resistive and capacitive divider and write the equation of the measured high voltage in terms of the elements of the divider. Okay, so he wants us to draw the circuit diagram for the resistive and the capacitive, and we have to write the both formula for the resistive and capacitive. Okay, and he give us here the value, the giving value, a high voltage divider with ratio R2 divided by R1, it's equal 80 divided by 5, is used to measure a certain high voltage supply. If the electrostatic voltmeter connected to the low voltage resistance arm R1 read 12 kilovolt. So the volt here, he give us the low voltage as a 12 kilovolt. He wants us to calculate the measured supply voltage. Okay, let's move on to the answer sheet to see how can we draw the circuit diagram for the resistive, and then how can we draw the circuit diagram for the capacitive, and how can we write the formula for both. Okay, so the giving value, he give us R2 divided by R1 is equal 80 divided by 5. Okay, the volt he give us a 12 kilovolt. So the resistive potential divider, always R2 will be greater than R1. Why? Because R1 is connected with the low voltage and R2 is connected with the high voltage. Okay, so here this is the drawing for the resistive divider. So this is the volt here, the voltmeter here is connected with R1, and this is the R2, okay, and this is the R2 here, and this will be the circuit diagram will be like this, okay. So the formula for the resistive potential divider is V high voltage here will be equal V into R1 plus R2 divided by R1. Okay, R2 is given as 80, R1 is given as 5, and the volt here is given as 12. So we can solve this question by using this formula. Okay, let's see the circuit diagram for the capacitive potential divider. So the C2 is always smaller than capacitor 1, okay, because this is the charging capacitor. So C1, it will be always the charging capacitor, okay. So this is the circuit diagram. It looks like this, the circuit diagram divider, and you will have a full knowledge about the divider with the theory part. I think you have already get this study this part. So the formula for the capacitive potential divider, VHV, it will be equal V into C1 plus C2 divided by C2. So here, in this question, he asked us to calculate the measured supply voltage. Okay, why we didn't use this formula? We use the resistive formula. Why? Because in the question he give us the resistance 1 and resistance 2. So we will use this formula to solve this question. Okay. So to solve this question, VHV, V high voltage, will be equal V into R1 plus R2 divided by R1. So V here is given in the question as a 12 kilovolt, and R1 is given as a 5, and R2 is given as 80, and R1 here it's given as a 5. So if you use your calculator, here, you will get the V high voltage is equal to 204 kilovolt. Also, you can use this formula. So this formula, it's also the same thing, but we only take R1 as a common value. So here, this is the common value, R1. We give it as 1. 1 into R1 is 1, and this is, as I said, this is a common value. We take R1 as a common value. So V high voltage will be V open the bracket 1 plus R2 divided by R1. So 12 kilovolt into 1 plus 80 divided by 5, you will get 204 kilovolt. And exactly, if you use this formula or you use this formula as you wish. So all of these two formula, it will give you the correct answer. So this is all for today in this session. So we have done tutorial 2. We finished all the question in tutorial 2. So if you have any doubt or any misunderstanding in this question, in this 3 question, I will be happy to help you and answer all of your questions. And thank you so much, guys. I will be waiting for your question.